This is part 3 of my radical review series. This is second whole page in your packet. You see the title here is Lesson 11.5, Operations with Roots. On this page, I'm not going to do too many review videos because they're very similar to the first two. However, you can ignore numbers 3 through 6 on this sheet unless you have a need for additional challenge in the class. 1, 2, 7, and 8 are the only that are going to be ones that are going to be covered on your on the test for this chapter. So don't worry about 3 through 6 as much, but 1, 2, 7, and 8 will definitely be on there. So give those a shot. Let me know how they go. As for the next page called Solving Radical Equations, let's go ahead and do a couple of these. You can see it in the directions there. It says to be sure to check for what are called extraneous solutions. What happens here when you solve these is you sometimes get answers that are false. They don't actually work in the initial equation, so you want to go back and make sure to check them. Let's go ahead and try B. B is a pretty straightforward problem. It says the square root of x plus 7 needs to equal negative 3 somehow. Okay, so let's go ahead and try to solve this problem by starting by squaring both sides. So the first step will be to square both sides. When you square the left side, the square and the square root cancel, and you get x plus 7 equals positive 9. Squaring negative 3 gives you positive 9. Remember, that came up on the last test. Some students got negative 9. It's positive 9. Next, we simply take away 7 from both sides, and you get the answer 2. So the solution is supposed to be x equals 2. Now, if we plug 2 back into the initial equation, it would say the following. 2 plus 7 equals negative 3 when square rooted. That's false. 2 is an extraneous solution in this problem. It doesn't actually work. The square root of 9 is 3, not negative 3. We redefined the square root symbol in this chapter to mean the positive square root only. Here's another way of thinking about this. In B, another way that you can get your solution to something like B is to graph. You could take y1 and you could plot it on a graph. You could make y1 equal to the square root of x plus 7 and graph it. Now we know from our studies that that would be a graph shifted left 7. And it would be a radical function, launching there at negative 7 and going up and to the right. The question is, when does that graph equal negative 3? Well, if you graphed y equals negative 3 in the y2 equation on your calculator, it would look like this. We have a flat line, a horizontal line down at negative 3. So the question is, when does this red graph meet with this blue graph? The answer? Never. They do not meet, and that's what makes 2 an extraneous solution. Interestingly, though, if we were to think about the entire parabola, if we were allowed to graph this entire parabola on its side, sorry about the curve there, out of control. If we were to graph the whole thing, guess where they would meet? Remember, we're not allowed to draw that bottom half of the parabola because it wouldn't pass the vertical line test. But if we were allowed to draw that bottom half, guess where they would intersect right here? The extraneous solution, x equals 2. The bottom line is, when you're solving these equations, you want to make sure that you plug in your answer and make sure it's not extraneous. Go ahead and work on A, C, and D, and let me know how you did when we meet in class. So, a couple words of advice here. In A, you want to take away 3 first, then square both sides, then add 4. In C, I would take away 4 first, then divide by negative 1, then square root both sides, then add 2. In D, here's the order in which you should solve it. Take away 5 from both sides, divide by that negative 1, divide by negative 1 to get rid of this negative sign, Square both sides. That'll get rid of the square root symbol. Divide by -1 again to get rid of this negative sign. And finally, subtract 4. Those are the steps you would take to solve for x. Don't forget at the end of that one, check x back into this equation. Make sure it's not extraneous. Have fun.